In this video, I'm going to be going over oxidation and reduction reactions. Oxidation and reduction reactions can sometimes be referred to as redox reactions. Redox reactions are classified by a reaction where there is a transfer of electrons. So, if we are met with a redox reaction like this one, the first thing we should do to see our transfer of electrons is decide the oxidation state for each one of these atoms. So, looking at MnO4 minus, to solve for the oxidation state, we should do MnO4 equals -1, the overall charge. So we do not have a rule for Mn, but we do have a rule for oxygen. We know that this is going to be X plus 4, because there are 4 oxygens, times each oxygen has an oxidation state of -2 equals -1. So X is going to equal +7. So the oxidation state for Mn is +7. We know the oxidation state of oxygen is -2. We see that iodine is on its own and it has a -1 charge. So we know that the oxidation state of iodine is simply going to be -1. Mn2 plus is on its own and it has a +2 charge. So its oxidation state is simply going to be +2. And I2 is on its own, so it has an oxidation state of 0. There is no charge here. So what we need to do, now that we have our oxidation states arranged, is decide which species gets oxidized and which species gets reduced. So what do these two terms mean? Oxidation and reduction refer to the losing of electrons and the gaining of electrons. So we need our oxidation states to decide which atom gets oxidized and which atom gets reduced. So looking at Mn, if we look at Mn went from an oxidation state of +7 to +2. So Mn must have gained 5 electrons. Remember that electrons carry a -1 charge. So if you go from +7 to +2, you must have subtracted 5 or gained 5 negatively charged electrons. So Mn was reduced. It gained electrons. Now, let's continue to look at a reaction to see which species gets reduced. Well, we see iodine go from a -1 oxidation state to iodine over here go to a 0 oxidation state. So for I, we see it go from -1 to 0. So we must have removed 1 electron. If we start with -1 and we want to get to 0, we would have to remove 1 negatively charged thing, which is 1 electron, to get to an oxidation state of 0. So because we removed electrons, iodine lost electrons or got oxidized. So we now successfully decided which atoms in our reaction get reduced and which one gets oxidized. So it's really important when you write a redox reaction or you see a redox reaction that you assign the oxidation state to each atom before you try to decide which species gets oxidized and which species gets reduced.